So now this brings to our next presentation by Eduardo Velázquez, entitled Limited Effects of Forest Expansion in Abandoned Agricultural Lands to Offset Regional Carbon Emissions Under a Mediterranean Continental Climate.
Okay, my name is Eduardo Velázquez, and I'm going to present some of the most recent results of the research that I have been performing during the last 2 years. So, forest expansion in abandoned agricultural lands is a very common phenomenon in some areas such as northern North America, Eastern Europe, and the Mediterranean basin as a consequence of the strong rural-urban migration processes that have occurred over the last decades. Forest expansion in abandoned agricultural lands has largely contributed to the carbon sink detected in the northern hemisphere as a consequence of the process of CO2 sequestration, which is involved in the vegetation's growth. This process is very important to update carbon budget and to redefine the CO2 emission reduction targets at country level in all these regions. This process, however, has been very studied in Eastern Europe over the last decades, but in the Mediterranean basin, we have just a few local studies, mostly focused in ecological interactions and in the accumulation in the soil organic carbon, but not in the above-ground vegetation and the below-ground vegetation. So the contribution of this process to carbon accumulation at a regional scale in the Mediterranean basin is still poorly understood. In this study, we aimed to control and to study the process of carbon accumulation in these abandoned agricultural lands through approaches combining above-ground carbon estimations based on field measurements with radar backscatter. In these approaches, we first taken biomass values in a forest plot. Then we calculate the carbon accumulated in the vegetation, in the trunks and the branches of the trees, and also in the roots. We make some regressions between the backscatter, that is the return signal of the radar, and this biomass, and using this regression, we propagate the model to the area in which we don't have biomass data to construct carbon maps. In our study, we applied this approach to our study area in order to assess the area affected by forest expansion in abandoned agricultural lands, to estimate the mean densities and stocks of carbon accumulated in the above and below ground biomass as a consequence of this process over the period 1957-2017 in Castilla y León, a vast region in central North Spain, very affected by the population over the last decades. So first of all, we mapped the areas in which agricultural abandonment has taken place. We superposed the aerial photographs of 1977, 1980, and when available, those of 1956 and 1957, with those between 2015, 2017, with the areas, with the vectorized maps, of different forest types according to the Spanish forest maps. In this area, for instance, you have the picture of 1977, and in green you have the areas that are currently covered by holm oak forest. You can see that many areas that are now defined as forests were covered or were used by cultivation in 1977. So this is the picture of 2017. We detected the areas that are now covered by forest, and then we created these figures, and we find the area occupied by abandoned agricultural lands. So once defined the areas occupied by abandoned agricultural lands, we randomly selected 5 study sites 2 of these sites were dominated by Quercus pyrenaica, and the other 3 were dominated by Quercus ilex, Juniperus turifera, and Quercus faginea, respectively. In these areas, we set 6 plots per study site, 30 plots in total. And in these plots, we measured in the adult trees the diameter at breast height and the height, in the juvenile trees and sapling trees, just the height, and in the larger shrubs, we took measures of the diameter at root collar, the height, and the 2 main canopy diameters. With all these measurements, with all these variables, by using allometric equations, we calculated the individual level above ground carbon and below ground carbon, the plot level above ground carbon and below ground carbon, and then by conversion factors, we finally found the plot level above ground carbon and below ground carbon. With these measurements, we took satellite images from the ALOS Pulsar satellite of the Japanese Aerospatial Agency. This is a very interesting satellite because it is emitting the radar beams in the L-band, so it is very interesting to quantify the biomass in areas in which the biomass is not so high and that are very spatially heterogeneous, such as that in our region. So we make the regressions between one of the 2 polarizations of the radar and the above ground carbon we have calculated in the plot. And with the raster calculator in the GIS, we found mean AGC density maps. By using the relationship between above ground and below ground carbon, we also calculated maps of below ground carbon density. So, for instance, here you have the areas affected by agricultural land abandonment in Losar del Barco and now covered by holm oak forests. So, this is the above ground biomass map, and this is the below ground biomass maps. Here you have a picture to see which is the appearance of this type of forest regenerated in former croplands. We also calculated the total above ground and below ground carbon stocks by multiplying by the area of the pixels and the equivalence between megagrams, or tons, and teragrams, which are millions of tons. This is the unit to express the carbon stocks usually. So, what do we found? First of all, 1.54% of the study area was covered by forests developed in abandoned agricultural lands. This is a very high proportion because in former studies in Ukraine, it was found that 1.12% of the current forests were occupied by this type of lands, and in the former Soviet Union, 0.75%. And Zamora has even a larger proportion. So most of these areas were located in middle mountain areas and not in isolated areas. So one of our study regions was relatively close to Madrid, and another one was just 100 meters away from the A55 highway. So we also find relatively high mean above ground carbon and below ground carbon density. So we found above ground carbon densities averaging 18.04 megagrams of carbon per hectare. This is relatively high, because some authors have found 45 megagrams of carbon per hectare as a mean average in Spanish forests. These densities were very high in some areas, such as those in the western part of the Cantabrian Range and in the western part of the Central Range, that are also the heavy rainfall areas within the study region. This area here was formerly a strawberry field up to 1967, and now we have a very dense Quercus pyrenaica forest. However, the total above ground carbon stocks and below ground carbon stocks were low. We found just 6.27 millions of tons for the above ground carbon and 3.73 millions of tons for the below ground carbon. This is relatively low, considering that in other studies, for instance, that of Scherhorn in 2013, they found 470 millions of tons in European Russia, Ukraine, and Belarus. So our numbers were relatively low. These numbers just contributed to sequester 1% of the total CO2 emissions of Castilla y León over the period 1991 and 2019. And this could be explained because there was a huge extension of poorly regenerated areas, mostly in the easternmost part of the study region, which didn't contribute to the total stocks of the region. So, some take-home messages. The forests, woodlands, and other wooded areas developed as a consequence of agricultural land abandonment between 1957 and 2017 occupy a large proportion of the area of Castilla y León and account for large mean above-ground and below-ground carbon densities, but the total above-ground and below-ground carbon stocks are relatively small. The ability of these forests to sequester more CO2 could be affected by the decrease in precipitation that has been predicted for the Mediterranean basin over the next decades, but the potential of these forests to sequester atmospheric CO2 should not be underestimated. Why? Because they could occupy an area larger than detected. Many of them might have not still reached their carbon uptake peak, and an appropriate management of these areas could enhance their role as carbon sinks. I would like to acknowledge all the people that has contributed to this work and to the organizers of this event, and thank you for your attention.